This instructional video is on textbook pages 271 and 272. For number 7, two rovers are exploring a planet. The system of equations below shows each rover's elevation y at a time x. What conclusion can you reach about the system of equations? So rover A, y equals 1.9x minus 8, is in slope-intercept form. The y equals is over on the left-hand side, the mx is on the right-hand side, and the plus b is at the back. However, rover B's equation is not correct. The 7y on the left-hand side needs to be moved. The 13.3x is good in the middle, and the minus 56 is fine at the back, but we want that y value to be by itself. To get the y by itself, we want to divide by the 7. On our calculator, 13.3 divided by 7 gives us a value of 1.9. And then 56 divided by 7 gives us a value of 8. We can then identify the slopes of our equation. So rover A, the slope is the 1.9x, and the y-intercept is the negative 8. Same with rover B. Our slope is the 1.9x, and the y-intercept is the negative 8. So for our statement, we would say that the slope for rover A equation is equal to the slope for rover B. The y-intercepts of the equation are also equal. They are both negative 8, meaning if both the slope and the y-intercepts are equal, it means it has infinitely many solutions. For number 8, how many solutions does this system have? The first equation, y equals x minus 3, is in slope-intercept form. The y equals is in the front, the mx is in the middle, and the plus b is at the back. We can identify our slope, which is a 1x, and we can identify a y-intercept, which is a negative 3. The second equation, 4x minus 10y equals 6, has some pieces that need to be rearranged. We want to take the 4x from the front and we want to move it to the middle. When you move a 4x, it changes to the opposite, so that becomes a negative 4x. We still have our negative 10y and we still have our positive 6. The last thing we need to do to write it in slope-intercept form is to isolate the variable, meaning get the letter y by itself. In order to get y by itself, we would divide. So we're going to divide by the negative 10. Negative 4 divided by negative 10 gives us a value of 0.4x. And then 6 divided by the negative 10 gives us a value of negative 0.6. Once your equation is in slope-intercept form, then we can identify the slope, 0.4, and the y-intercept, negative 0.6. Because we have different slopes, we have a one solution problem. Number 9, how many solutions does this system have? Again, we're referencing our equation y equals mx plus b. Starting with our first equation, we need to move our mx piece from the front to the right-hand side middle. When we move x, it would change into a negative x, and we know that that is really a negative 1x. So our 3y, we now have a negative 1x, and we have a plus 0. We don't have to write plus 0, it doesn't change the equation, but you can if that helps you visualize it. The last step we need to do is isolate the variable y. To get y by itself, we're going to divide by the value 3. Negative 1 divided by 3 gives us a repeating decimal, which as a fraction would give us negative 1/3 x. And then 0 divided by 3 is 0. Again, you don't have to write the 0, but if it helps you visualize it, you can. Meaning our slope is the negative 1/3 and our y-intercept is 0. For the second equation, 12y equals negative 4x. On this one, the mx piece is already on the right-hand side. All we have to do is isolate the variable. In order to get y by itself, we would divide. -4 divided by 12 gets us a repeating decimal of -1/3 x. And then that's all that's left in the equation. Meaning our slope is a -1/3, and our y-intercept, which is nothing, is 0. We can see that both the slope values and the y-intercept values match, meaning we have an infinite solution. For number 10, what can you determine about the solutions of this system? Again, we are referencing slope-intercept form, y equals in the front, mx in the middle, and plus b at the back. Our first equation, -64x plus 96y equals 176. We are going to start by moving the mx piece from the front to the right-hand side. When we move a -64, it changes to a +64. So we have the 96y, we have our now +64x, and then we have our 176 at the back. In order to isolate the variable and get the y by itself, we are going to divide by the 96. On your calculator, when you divide 64 by 96, you end up with a repeating decimal of 2/3. So we have y equals 2/3 x. We also divide the 176 by the 96, which again gets you a repeating decimal. As a fraction, you would write it as 11/6. So our slope is going to be our 2/3 x, and our y-intercept is going to be the 11/6. We're going to solve the same equation, 56x minus 84y equals -147. Same process, we start by moving our mx piece to the other side. A 56 is going to change to a -56x. We still have the -84y with our -56x and our -147. Our final step is to isolate the variable. To isolate the variable y, we divide by the -84. On your calculator, when you divide 56 by 84, you get a repeating decimal of 2/3. You also divide the 147 by the 84 to get a value of 7/4. We can identify our slope as 2/3 x and our y-intercept as 7/4. Because the slope values match, but the y-intercept values do not, it means we have a no solution equation. Number 11, determine whether the system of equations has one solution, no solution, or infinitely many solutions. So because we have a +8x for our first slope, and we have a -8x for our second slope, those are considered different. So we have different slopes. Different slopes means we have a one solution problem. Number 12. Maya says that the two lines in this system of linear equations are parallel. Is she correct? If she is saying they are parallel, that means that she is saying that they have no solution, meaning they would have the same slope and different y-intercepts. So looking at the two equations, 2x plus y equals 14, we would need to rewrite the first equation. Our 2x would change into a -2x when we move it, meaning our equation is y equals -2x at a +14. Our slope would be the -2x, and our y-intercept would be the +14. For the other equation, we have 2y plus 4x equals 14. Again, we start by moving our 4x, making it a -4x. So we have 2y, our -4x, and a +14. To isolate the variable, we want to divide by the 2y. Negative 4 divided by 2 is negative 2x. 14 divided by 2 is 7. So again, we would show that our slope is a negative 2x and our y-intercept is a positive 7. So we can say that yes, Maya is correct because they have the same slope, negative 2, but they have different y-intercepts, 14 and negative 7.